Okay, let's see what's cooking, huh? Kind of a pun. So here's my RF shielding, so I won't grow cancers all over my body from radio waves. So this is interesting. I have this bifilar transformer. It's got a ferrite core. I have this connected right across the two wires going in here. It's like one here, right to the primary of the bifilar transformer right here. And here's the output here. This is on 7 out of about 12 or 15. So I can make it brighter. But so it's right there at 7. Power level 7. Kitchen HQ. These are $39 on eBay. And here's the spiral flat coil stack. Now what is interesting is I have this meter, 20 amps AC, and I was just fooling around here. Wonder what happens when I short it out. So I shorted the secondary of this transformer out, and the lights still stayed bright, but they, still stayed lit, but not so bright. So I thought what I'll do, instead of just a wire across there to short it out, I'll do a ammeter in AC. And look what happens. Those are still lit, and it says about 10 amps AC going across the secondary, just shorten it out. And here's what's interesting. I guess it makes sense. But when I take out power with the transformer, the draw goes down. This is this ammeter here is from the grid at 60 hertz, so this is accurate, coming from the grid. So if I take this off, it's about 6 amps going in there, but I apply the load of this transformer being shorted out on the secondary side, and it drops down to about 4 amps, maybe 5. Maybe it's kind of growing back up. Let's see how that is again. Here it is with just the transformer across there. Nothing happening with the secondary. It drops for a while, and then it actually comes back up for about to where it was. But you can say that there's no, remember, this is the amps from the 60 hertz grid right here. So this is accurate. So that's quite interesting. Here's the 2 wires connected to the full wave bridge rectifier, because the way these work is the 120 volts comes in, it's rectified to DC with a full wave bridge, and then that 120 volt, it goes up to 175 volts in DC, and that gets chopped at 24 kilohertz. by an IGBT. This is getting just a little bit warm. Not hot, but a little bit warm. That's okay. Not worried. So there's the amps going across the secondary, shorted out. It's a lot of amps. More amps going across the secondary than is going into it. Not that that means anything, but that's what's going on. Okay, this is just a quick test today. Wanted to check out my aluminum cooking pan Faraday cage. Okay, thanks for watching.